Okay. Hello, Maisa.
Hello, ma'am.
Hello, Rana Shehbaz.
Good morning, ma'am. How are you?
Good morning. How are you?
I'm fine, ma'am. Thank you.
Hello, Amelia.
हेलो मैम.
ये कौन है? ये रोल नंबर लिखा हुआ है, नाम नहीं लिखा हुआ है अपना. प्लीज टेल दिस पर्सन टू रीनेम themselves. Send a message on the group. Somebody please send a message on the group that you have to rename yourself so that I can recognize you. Okay? If I don't recognize you, I cannot let you come into the class. 49723 231 49. ठीक है. 23149723 231497231. ये कौन है? Tell this person to use their username. Hello, Hunain. हेलो बेटा, अपने आप को रीनेम करो. अपने आप को रीनेम करो. राइट योर नेम देयर. अपना यूजर आईडी को रीनेम करो, नहीं तो आई विल रिमूव यू फ्रॉम द क्लास. ओके हुनैन? Hunain, rename yourself. I'm going to put you in the waiting room, okay?
Good morning, ma'am.
Good morning. Who is this?
Sabira Mubashir.
अस्सलाम वालेकुम मैम.
गुड मॉर्निंग मैम.
बेटा नाम भी बताया करो.
इब्राहिम इरफान.
इब्राहिम. और दूसरा?
अली जुल्करनैन.
अली जुल्करनैन. गुड. अच्छा.
Good morning, ma'am. Sania Ahmed.
सनिया अहमद. गुड मॉर्निंग. ओके. किसी ने मैसेज किया ग्रुप में? अच्छा. Okay, so let's start. Right? I'm going to share the book with you. Okay, share. Okay, so this is what we were studying last time, right? So we were talking about rotational motion, angular momentum, angular velocity, energy related to that, right? And systems of particles. So these are the topics we are talking about. So we will continue this and we will talk about the related concepts, the formulas, and apply these to solve problems. So one of the equations we've been talking about is the velocity relationship between the linear velocity or translational velocity of the center of mass of the system. This is Vcom with the angular velocity, which is omega. And when you multiply this with the radius of the circular path, you get this V value. Okay, so this is a very simple relation. There's a table also that gives you such relations and the correspondence between translational quantities and angular quantities. Okay. So then we talked about the fact that rolling motion or rotational motion also has a kinetic energy. And kinetic energy in simple linear translational motion is half mv squared. In case of translational motion, it depends, instead of the mass, it depends on the rotational inertia I. And since we are now saying that every body is composed of a system of particles, therefore we relate this to the center of mass of the system of particles. And instead of V, we use omega squared. And then we also multiply this with a term which depends upon Vcom. So these formulas have been studied in this chapter. So just like we related the velocity V for translational motion to the rotational velocity omega, we can also relate the translational acceleration A to the rotational acceleration alpha. In the same, you can see the relationship, it's very similar. We also defined the value of A in terms of on an inclined plane, and which an inclined plane can also be called a ramp. So in that case, you see that when you draw the force diagram, the normal force and the gravitational force, you see that there's a sign component there, and this is the relation that you get. Now, since the topics we are studying are related to rotation, so in rotational motion, you have the quantity torque, and this torque is similar to force in translational motion. And the relationship between these two quantities is that torque is equal to the cross product of radius and force. So therefore, it's either the perpendicular component of the radius multiplied by force, or it is the perpendicular component of the force multiplied by the radius. So therefore, it has to be, the two quantities have to be perpendicular to each other, and thereby they produce a torque. We also talked about angular momentum. Angular momentum, the formula is L is equal to R cross P, again a vector product. So this is a vector quantity. Also, we have the same concept of taking the perpendicular component of the radius multiplied by the translational momentum. Okay, so this we talked about these formulas in the last classes. Then we talked about Newton's second law. You know, from the beginning of this course and also before this, when you were studying Newton's laws in metric and FSC and O levels, you came across the simple form of the Newton's law, which was F is equal to ma. Now, when we talk about circular, angular, rotational motion, instead of F, it becomes the torque, and this becomes dependent on the angular momentum. So there are a number of relationships that can be related, that can be written for Newton's second law. So Newton's second law can be written in terms of momentum, it can be written in terms of torque, and it can be written in terms of force, depending upon the case that you're considering. Angular momentum of a system of particles, again, just like we studied in the previous chapters, that in the beginning of the course, we were talking about a body being approximated to be one particle, but then to be more accurate, we know that a body consists of a system of particles. And therefore, any quantity will be the sum of all the quantities for each particle. And then therefore, we have this summation sign, and this is for angular momentum. So angular momentum for one particle is represented by a small l, but for a system of particles, it's the summation of all the small l's, and you get a capital L. Similarly, you can write the same torque equation in terms of system of particles using a capital L. And angular momentum can also be written in terms of the moment of inertia or the rotational inertia, which is I. And then just like we had the conservation of energy, right? We also have a conservation of angular momentum, which means that the initial angular momentum of a system is equal to the final angular momentum of a system. So we talked about crystallization and a gyroscope, and last time I showed you a video about this. I also uploaded some material to Moodle regarding this, and I also, of course, uploaded the recording of the last class in YouTube. So you can also subscribe and watch that. So, okay, so now we are going to apply these concepts and solve problems related to these topics. Okay, so for this purpose, let's go to a problem. Okay. Let's start with this one. So in this case, this is a problem on, as I'm sharing with you. So the land speed record was set in a desert in this for a car, which had a speed of 1222 kilometers per hour. And in one direction, and in the opposite direction, it had a velocity or a speed of 1233 kilometers per hour in the opposite direction. Both speeds exceeded the speed of sound at that location. Okay, so it was very fast. So setting the land speed record was obviously very dangerous for many reasons. One of them had to do with the car's wheels. You know, in circular rotational motion, even in linear motion, we have been talking about problems related to the safety and what are the danger and risks factors in this case. So in this case, again, it was dangerous for many reasons, and one of these was that the car's wheels, if we approximate each of the wheels as a disc of uniform thickness, you know the shape of a disc, you know, it's circular and having a small thickness, right? So this is a disc shape, just like the wheel is also a disc shape, right? Like this. So, so if we assume that the wheel of the car is a disc of uniform thickness and has a certain mass, let us say 170 kg, and assume smooth rolling, then when the car speed was 1233 kilometers per hour, what was the kinetic energy of the wheel? So the question is about kinetic energy. So in order to solve this, we have to look at the appropriate equation for kinetic energy. And this is related to the article we studied here, in which case the kinetic energy is given by this equation, right? So this is the equation that we will use for this. Okay, so in this case, we know that the formula for I can be obtained from the table we had in chapter 10. You remember that table? For a uniform disk, I can share this with you. I can share this table with you. So, okay. Can you see this table now? Can you see the table?
Yes, ma'am.
So we are talking about a disk, and the formula for a disk is, this is the formula we are going to use. You look at the description here. This is a solid cylinder or a disk. So this formula is valid because the rotation and the shape are similar. You know what a disk means. A disk will have a smaller thickness and a larger radius, but the shape is the same and the axis of rotation is the same. So therefore we can use this formula for rotational inertia, which is I is equal to half mr squared. Okay, so study this table carefully. You will see that this shape and this shape is the same, but the formulas are different. What is the difference between a C and D? Who will explain the difference between C and D? Yes, I will give you a point for this. Who will explain this difference? Bolo? Hello?
Ma'am, the axis is
Naam
different.
bolo apna pehle.
Arisha.
Arisha, yes, Arisha.
In C, the axis is going through the diameter of the cylinder, and in D, the axis is going through the middle of the cylinder. The diameter is untouched.
Okay, good. So it's the axis
यानी
of,
कि in D, the
bolo, Arisha.
so D, the axis is going through the length.
Okay. So you see that in this case, this formula is for a solid cylinder or a disc. This formula is also for a solid cylinder or a disc. But the difference in this case is this, that the axis of rotation is passing through, let's say, the center of this circular face, right? Whereas in this case, you see the axis of rotation is not passing in this direction, rather it's passing in a direction that's perpendicular. And you see that if the axis of rotation changes, then the formula for I will change. So please try to understand how to find the appropriate formula according to the problem you're solving. Is that clear? बात समझ में आई?
Yes.
Okay, who will explain what's the difference between F and G? What's the difference between F and G? Yes, who will explain the difference between F and G? Bolo? Who will answer this? I'll give you a point for this. Who's going to answer this?
He
Yes.
said that one is hollow and the
Naam
other
bolo,
one is
naam
filled.
bolo pehle.
Fareed.
Fareed, yes. So, yes.
One is solid, one is solid, another one is hollow sphere.
Very good. So this one is solid and this one is hollow. So you understand the difference between solid and hollow?
Yes, ma'am.
समझ आ रही है?
Yes.
Can you give me an example from real life?
Real life, ma'am, the hard ball we play is solid, but the other kind of plastic balls we play, they are hollow spheres.
Okay, good. Okay, so now we, in the example we are solving, we are going to use this formula, I is equal to half mr squared. So now I'm going to go back to the problem that we were solving and I'm going to share it with you. Okay, so we talked about the formula and this is the formula we got from the table, half mr squared. And instead of omega, we are using Vcom divided by r squared, just as I discussed in the beginning of this class, right? So because we have the value given for these quantities, and then we can substitute these values. Okay, so when we will see that this r squared will cancel with this r squared, this one will cancel, and this one will cancel. And you're left with 1 over 4 m into Vcom. So this is 1 over 4 m into Vcom plus half m. This is squared, okay? So this will be squared, half m Vcom squared. And when you add these two quantities, you will get 3 over 4, okay? So 3 over 4 m Vcom squared. The r gets cancelled. Now you know that the value of m is given as 170 kg. The value of v is given as 1233 kilometers per hour. You have to change it into meter per second squared. So this is the conversion. Remember the units, you always have to see the units and see how you're going to use them. Are they okay to be used as they are, or do you have to convert them? Since kg is an SI system of unit and kilometer per hour is not an SI system of unit, so therefore you have to change it to a SI system of unit. And then when you multiply these quantities, you get the kinetic energy, and the unit for energy is joule. So this is the solution for this problem, in which we've utilized the formulas for the moment of inertia. We've utilized the relationship between V and omega, and we've utilized the formula we studied last time for the kinetic energy of such a body. Okay. So now we go to the next one. Okay. So let's talk about this one. In this case, we have a uniform ball of mass m is equal to 6 kg and a radius capital R. It's rolling smoothly from rest down a ramp at an angle of 30 degrees. So, you know, we studied last time motion on a ramp, this motion that you saw last time, and then the formulas that we discussed about this motion. So this is what this problem is about. And we have to find the ball descends a vertical height h is equal to 1.2 meters to reach the bottom of the ramp. So what is the speed at the bottom? So I would like you to think about this while I take the attendance, okay? And then we discuss this problem, okay? Another thing, Rana Shehbaz, you were asking me previously about the midterm you know, mistakes that you made. I have made them available. You can check them in Moodle. Okay.
Thank you, ma'am.
Yes, you're welcome. Okay, so Sarmad, Amar, Abu Bakr. Okay, so let's see who's here. Fatima, Usman, Anam, Muhammad Bilal.
Yes, ma'am. Mohammed Bilal here.
Okay. Hamza Dar. Hamza Dar. ये हमजा डार लॉग इन करके गायब हो जाता है.
यस मैम.
कौन बोल रहा है?
हमजा डार.
हमजा डार, आप गायब क्यों होते हो?
मैम मेरा माइक ऑफ था.
नहीं ना, ऐसे नहीं करते ना. आप क्लास में हो, so you should know that.
यस मैम.
ठीक है? You should
ओके मैम.
alert.
ओके मैम.
अच्छा जी. So और कौन है? Let's see. फरीदुद्दीन.
Yes, ma'am.
Kessler. Zaresh. Haris.
Present, ma'am.
Okay.
Haris.
Okay. Muaz. Ibrahim.
Present, ma'am.
Good. Huma. Alina.
Present, ma'am.
Okay.
Alina.
Okay. Yes, please say your names. Hunain. Hunain को मैंने कहा था to change his user ID and then enter the class, but I don't know what's wrong with him. अच्छा. Rana Shehbaz.
Present, ma'am.
Sania.
Present, ma'am.
Okay. Arisha.
Present, ma'am.
Please switch off your mic if you're not speaking, okay? So, Chand.
Present, ma'am.
Maiza.
Present, ma'am.
Okay. Yusuf Patras. No. Abira.
Present, ma'am.
Okay.
Present, ma'am.
Good. Nadia.
Present, ma'am.
Good. So Nadia is here today. Okay. Hayan.
Yes, ma'am.
Okay. सोच के बोलते हो Cheryl? No. Ashraf? No. Huda? No. Amelia?
Present, ma'am.
बेटा सोच के बोलते हो.
Amelia.
Bisma?
Present, ma'am.
Okay. Sadikula? No. Sohaib?
Ma'am, present.
Okay. Talha? No. And Ali Zulkarnain?
Present, ma'am.
Good. Okay, that's fine. Okay, right. So now coming back to the problem we were discussing, let's continue. So did you think about this? So we have to find the speed at the bottom. We know that the motion is on an inclined plane, it's on a ramp. So this was the related figure and the related diagram. So this problem is relating to this figure and to these formulas. Okay, so we have to find this. We know that from the conservation of energy, E final is equal to E initial. So Kf plus Uf is equal to Ki plus Ui. Now, we know that U is the potential energy and the formula for this is mgh. So initially the formula Ui is equal to mgh, where m is the ball's mass. The final potential energy is equal to 0 because when the height decreases, it comes to the bottom, h becomes 0 and uf becomes 0. So we have the value for ui, we have the value for uf. Now for kinetic energy, since the body is starting from rest, therefore the initial kinetic energy depends upon velocity. So the initial velocity is 0, therefore the initial kinetic energy is 0. And the final kinetic energy Kf has a value, and we are going to talk about this. So we know that the kinetic energy, just as we discussed in the formulas and the concepts, and also the examples that we are doing, the problems, we know that in the case of a rolling motion, when a body is rolling on an inclined plane, the kinetic energy is a sum of the translational and rotational motion. So the motion is both translational and rotational. You will remember this from the previous class also. And therefore, we have to use equation 11.11 and put all these values. So kinetic energy for rotational motion, as we know, is given over when we were discussing these formulas. We saw the kinetic energy. You know, when I was doing a review in the beginning, the kinetic energy is the sum of the translational and rotational motion. So this one is for the rotational term, and this is for the translational term. I just did a review at the end of the chapter. Also, you have these formulas, and within the chapter also you have this formula. So this is the final kinetic energy. This is K final. So K final is here, this one. And then we know that the final potential energy is 0. So this is UF. And then we know the initial kinetic energy Ki is 0. And then the initial kinetic potential energy is mgh. So putting these values, we can now go further and we can do the calculation. So we know that the acceleration formula is given by this, as we've just discussed before today also. And in the, this is the formula we found last time for such a kind of a motion, right? When we're going on a ramp or an inclined plane, and you have translation as well as rotation. So for this formula, we know the value of chi, we know the value of theta, we know the value of ICOM. We just discussed ICOM from the table, right? And then we can put all these values together. So when you see this, you will see that G sine theta 1 plus the formula from the table that we discussed, for the last problem. That same table gives us the formula 2 over 5 mr squared for a ball, for a solid ball, as we were discussing, and this divided by mr squared. So you will see that mr squared will cancel with mr squared, and you will be left with these quantities. You know all of these quantities, so you can use your calculator to find sine theta, multiply that value with 9.8 and divide it by this sum, and this is the answer you get for the acceleration. Okay, so we did not need the value of the mass or the radius because these quantities canceled out. So don't get scared if you don't have some value. Do work through, and many times there are many quantities that cancel out and therefore they're not needed. Okay, and you can use them. So this was for the second part in which we were finding the frictional force. VCOM, of course, you got VCOM from this formula. So this has already been calculated here. This we have discussed this. Now for the second part, we are talking about the frictional force on this ball. So for the frictional force on this ball, the formula we are using is this. Again, we have already discussed this formula before. You know, this is the formula we are talking about, this formula, right? And in order to use this formula, we needed ACOM. So we have already found ACOM here, and we can put these values. We know ICOM from the table. We found ACOM from here. We substitute these values and we get this quantity, right? And for this quantity, we can again substitute these values and we can find the answer for the frictional force. In this case, we use a value of M, which is given, which is 6 kg, right? We use a value of ACOM, which we calculated, and the rest is just a multiplication, okay? So, and therefore, we have found these values, and so the problem is not really difficult. Actually, it's the same concepts. You have to identify the concept applicable, then you have to find the formula that's applicable, and then you have to see how you're going to use it. Is that clear? Okay. Hello?
Yes, ma'am.
Okay. And remember that when this meeting ends, you click the same link again to rejoin. Okay? Right? Another thing I would
Yes, ma'am.
Okay, I also want to draw your attention to your homework. So for that purpose, I would like to, I've already notified you about your homework before. Let's do it again. So for this purpose, your homework is to prepare for the graded homework 3. You can see my board, right? So these are topics 6, 7, 8. If you look at the course outline, I told you that the topics correspond to different chapters. I've been talking about that. So topic 6 corresponds to chapter 7 and chapter 8. Okay, so please prepare these. Topic 7 corresponds to chapter 9. So this is chapter 9. And topic 8 corresponds to chapter 10 and 11. So this is corresponding to chapter 10, because there's an overlap on these chapters, right? These topics are discussed, the same topic, the same concept is overlapping in different chapters. So you have to study chapters 7, 8, 9, 10, and 11 to prepare for your homework 3, which is a graded activity, and I will upload this homework in a few days and then you solve it. And it's very useful for you to prepare these chapters, because these same chapters will then come in the quiz, okay? And also they will be a part of the final examination, okay? So this is your homework for the theory class. For the lab class, today I have uploaded the material for lab number 8, okay? So please study and practice this material. Uploaded material. And not just the uploaded material, I've also given you the links for the virtual labs, and practice these concepts in the virtual lab links.
मैम एक्सक्यूज मी
जी कौन बोल रहे हैं?
मैम फरीद
Yes.
मैम मिड से पहले वाला सिलेबस फाइनल में तो नहीं आएगा?
बेटा आपके पास कोर्स आउटलाइन है ना?
यस मैम.
उसमें देखो.
ओके मैम.
उसमें देखो क्या लिखा हुआ है. आई हैव रिपीटेडली शेयर्ड दिस विद यू, सो प्लीज आप भी देखते रहा करो, उसको मार्क भी किया करो, ठीक है?
ओके मैम.
राइट. सो मैं दोबारा शेयर करती हूँ आपके साथ. I will share the course outline. Okay, So you can see this course outline, ठीक है? You can see the topics and how I have related them to the chapters. You can do this yourself as well. So 5 chapters you have to prepare now, and these correspond to the homework 3 graded activity that will be uploaded in a few days. As I told you that you cannot cram it in one day, so please study regularly the concepts and use them to solve problems. And also there's someone, Iman Khan, trying to enter the meeting, but I'm not allowing this person because I don't think this person is in our class. So please, I've already given a message in the group that you should have a proper username that corresponds to the name in my class list, and then you can be allowed to enter. Okay, is that clear? I don't know who Iman Khan is. Okay, so after this, we will have 2 chapters left to go. The 2 chapters remaining after this will be chapter 15 and chapter 13. So you see the order of the chapters is also not the same as the order of the topics. So these are, we have covered up till 11. We have 2 more to go, and then we would have completed the syllabus for the. Karamat Khan is not a student in the class. Ye kaun log aana cha rahe hain meeting mein? What's the problem today? Acha. So you can see these details here. The topics have been defined. Please relate them to, you see the topics for the final term exam are from topic 6 to 10, which correspond to the chapters that I've just showed you. Okay, Fareed? Does that answer your question?
Okay, ma'am. Yes, ma'am.
Yes. So you have all the details given here. But the course outline that I'm showing you is in terms of topics. I've been telling you this. Please relate them to the chapters and prepare accordingly. So the chapters are from chapter 7 to chapter 11 in order. And then we have chapter 13, chapter 15, which we will cover after these holidays. Is that clear? ठीक हो गया?
Yes, ma'am.
Yes, ma'am.
Great. Okay, so now we come back.
Excuse me, ma'am.
Who
Rana
is this?
Shahbaz.
Yes.
मैम आपसे मिड का एक एमसीक्यूज डिस्कस करना था.
MCQ number वो बताओ, statement बताओ.
Ma'am, and if a block is placed in an elevator moving with a constant acceleration, in comparison to mg, the magnitude of the normal force will be.
अच्छा, midterm वाला. ठीक है, ये next class में हम discuss करेंगे. ठीक है?
Okay, ma'am.
Elevator वाला problem आप discuss करना चाह रहे हैं. यही बात है ना?
जी ma'am.
ठीक है, next class.
Thank you, ma'am.
You're welcome. Okay, so now let's go. Let's see. Okay, now I would like to discuss a problem with you. This is 11.8, and in this case, I'm going to read out the statement. So you have a disk. You all understand what a disk is, right? You can imagine a circular plate like a CD, right? So you have a disk. It has a certain radius, capital R. Now a cockroach here is sitting on this disk, and the disk is rotating around a rotational axis. Is that clear? ठीक है? So in this,
Yes, ma'am.
okay, fine. So the cockroach is initially at a position which is not at the edge of the disk, but a little bit inside. So the radius of the cockroach from the center of rotation is small r, whereas the radius of the disk is capital R. Now small r is equal to 0.8 of capital R initially. Okay. And then later on, the cockroach moves to the end of the circumference, to the edge, to the outer edge, and at that time, small r becomes equal to r. The value of omega I is given here as 1.5 radians per second, sorry. And the mass of the disk is given as 6 m. Okay. So this is an example of a merry-go-round. You know what is a merry-go-round? The kind of झूले जो लेते हैं आप लोग amusement parks में, you know, a lot of the concepts of angular motion, rotational motion are involved on them. Okay, so I leave you with this problem. I am going to end the meeting here and then start it again. Is that clear? ठीक है?